guys. I hope you're enjoying your days off. I have been having the best time over the last couple of days meeting with you guys and your parents, and I've just been so proud of the work that you've done, the work that you've put into your PowerPoints, and I've just been thrilled to share your growth and your accomplishments with your parents. So it's just been the best time. I hope you guys are feeling proud. I know your parents are feeling proud, and I'm feeling proud. So I hope that you take some time over this day and whatever is left of it to really reflect on trimester 1, consider those goals that you've set for yourself, and just really give yourself a big hug because you all have been doing amazing things, and I cannot wait for this continued amazingness. I have 5 more conferences. I'm recording this during lunch and I was actually we're getting into lesson 26, and we're going to be doing long division with decimals, and gone are the days where we can rename our remainders as remainders. Now what we're going to go back to, and I know that we've practiced this already, we're going to go back to renaming the remainders as decimals. And remember, we know how to do this. We kind of temporarily stopped doing this. We can do that by dropping a 0 and converting those remainders to decimals. So you'll see some of those examples, and if I know I'm being confusing about communicating that, but I think in a second when you see that it'll sound familiar. But what I'm actually going to do is I'm going to do a throwback video, because the throwback video, the video from last year for lesson 26, is so cute. I could not resist it. The intro has baby Georgie, and he's so little. He's only, how old is he? He's July, August, September. He's only 5 months old. He's not even walking. He's really little. And then there's also baby Cal, who was just a brand new 2-year-old in this video. So I think it's an awesome video, and Mama's tired, so I figured I'd record a new intro, and then I can use the throwback video, which is very high quality work, if I do say so myself. You guys are responsible for previewing the content that we are all going to be working on together tomorrow in class, which is Friday. It's a throwback video, so I think I'm referring to seeing you guys again on Monday, but please know, yes, you're invited to come back tomorrow, which is Friday, 2018 school year. We're going to pick our secret snow bunnies, and we are going to do some arts. I'm so excited. We're going to have our first art projects, and then we're also going to sneak in some learning, some other learning. And please make sure that you do complete one full problem in your math notebook. Please make sure that you do document your word problem somewhere in your math notebook. Well, not somewhere, but under the proper date. And bring your math notebook back tomorrow and show up ready to learn. We're going to have a lot of things to get through in a Friday. But again, I'm proud of you guys and have been missing you all, having us all together, and can't wait to reunite tomorrow. Okay, so here I'm going to go ahead and edit in the sweet, sweet intro from last year with my babies. And then in between, we're going to do some really great math. Okay, guys, enjoy. It's the weekend. Georgie and I are still in our jammies, but we are going to get into lesson 26. We are dividing decimals, and it's going to be so exciting. Oh my gosh, Georgie. We are getting into the standard algorithm. Ooh, I'm wearing a scrunchie. I wear a scrunchie on the weekends. And it's going to be pretty straightforward. We're going to continue using a little bit of that estimation to guide our first quotient, or I guess all of our quotients. So we're kind of synthesizing and gathering all the skills that we've been working on recently and applying them into our work in lesson 26. And we're going to continue checking our work. Georgie, are you so excited? Yes, I'm very excited about math. I love math, Mama. And yeah, that's about it. I guess you guys we'll see in a moment what we're in for, but stay tuned and it'll be great. And happy Saturday. Say bye-bye, Georgie. Bye, 5th graders. Keep up the great work. Hey, kiddos, here we are. Again, this is lesson 26. We have just 3 more lessons until we get to the end of our module, and Mr. Calamaris is excited about that. Georgie's feelings are a little hurt because he's been taken out of the video, but he is standing by with Mr. Calamaris for support, so if you hear any strange sounds, that's Georgie, not me. Okay, so we are going to divide and then we're going to check using multiplication. I have some sad news for you all. Remainders are no longer a thing. Moving forward from lesson 26 on, we are going to convert remainders to decimals. Grab the Kleenex. I'm sure Kyle might be getting a little emotional right now, but it's okay, buddy. Kendi's there for you, and we're going to get through this. Okay, let's look at 36.14 divided by 13. Oh, Georgie. Georgie said that we can't get away with remainders anymore. 36 and 14/100ths divided by 13. Let's think about how many 13s can fit into 36. 1, more than that. 2, ooh, I feel like 2 might be a good number. We're still going to use this side over here to do some side work. And do not erase this work because you can use it throughout your problem. I think a lot of you have seen this work to be very helpful. Okay, so we have 13 times 2. What is 13 times 2? Thank you, Anna. It's 6, and then 2 times 1 is 2. I think this is going to be a really good start. So let's start with our 2. We already know 2 times 13 is 26. What is, 26, Mrs. Calamaris? What is the difference between 26 and 36? Chloe? It's 10. Thanks, Chloe. Now we have to ask ourselves, is this number smaller than this number? Yes, it is. If the answer would have been no, then we would have to go up here and reevaluate our quotient. This number must be smaller than this number because if it's larger than this number is larger than this number, we know that we can squeeze another 13 into 36. But 10 is smaller than 13, so we can move on with our life. Okay, so now what we need to do is we need to bring down that 1. So now we're looking at 101 and 13. Now we're trying to figure out how many 13s squeeze into 101. I'm going to round 13 down to 10. And, I'm not even going to skip count by tens because you guys know how to do that. And I'm going to think about approximately how many 13s can we fit into 10. I know the number has to be a single digit. I'm kind of thinking about 9, but I feel like that could be too large. This is really easy multiplication over here, so I'm just going to check out what is 13 times 9, and then we can make our decision from there. 3 times 9 is 27, carry the 2. 9 times 1 is 9, plus 1 is 11. That's too large. 117 is more than 101. So we know that 9 is too many. Let's go down to, we're going to decrease the 9. I'm going to decrease it down to a 7 and see what we get. 7 times 3 is 21. I feel like this might be a good place. Let's try this. Let's try 7 13s squeezing into 101. And please pay attention to your place value alignment. We've done this before. We know we're just going to bring that decimal up. 7 times 13, we've already done the work over here, it's 91. Now the only thing that we need to do is find the difference between these two numbers. Who can help me with this? Alex, 1 minus 1, 0. Thanks, bud. What about 10 minus 9? 1, thank you. Okay, cool. So now we have 10 versus 13. Is 10 smaller than 13? Yes, then we know that we're in good shape. We are going to now bring down our 4. Now we're looking at 104 and 13. We're trying to figure out how many 13s can we fit into 104. Well, we used 7. We were able to pull out 7 13s from 101. Now we have 104. I wonder if we can increase 7 slightly to an 8. Let's see what our product is between 13 and 8. 3 times 8 is 24. Abdullah, 8 times 1, thanks buddy, is 8 plus 2, 104. Ooh, this is really exciting. These are the same numbers. So can anyone make a prediction as to what's going to happen once we evaluate the rest of this problem? I think Anna's thinking about that. Keep that in your head for a second. Let's see if Anna's wish is going to come true. So according to our work over here, 13 times 8 is 104. Okay, so what we have 104 and 13. So it looks like we can squeeze 8 13s into 104. Okay, so notice this place value alignment. I'm putting the 8 right above the 4. Now 8 times 13, we've already done the work over here. It's 104. And Anna, what is our difference? It's nothing. Woohoo! So our answer is 2 78/100. Fabulous work here, guys. One more thing, actually, before we go. We're going to check this using multiplication. So now we need to multiply 2.78 times 13 and see what we get. Hopefully, we get 36.14. Okay. So 3 times 8, thank you, Miles, is 24. 7 times 3 is 21 plus 2, 23. Carry our 2. 3 times 2 is 6 plus 2 is 8. Okay. We're going to our second row now. We're going to multiply this 10 into 8, 7, and 2. It looks like a 1, but you guys know it's not a 1. It's a 10. So anything that we multiply by 10 is going to end in a 0. I'm going to go ahead and put that 0 in first. Now we just have to do really simple multiplication. 1 times 8, thank you, Claire, is 8. 1 times 7, thank you, Adbay, is 7. 1 times 2, thank you, Gabby, is 2. Now, Eric, what do we do with these two numbers? We add them together. Thank you. So we have 4. Thank you. Ira was thinking about that. 3 plus 8 is 11. Carry our 1. 9 plus 7 is 16. Carry another 1. 2 plus 1 is 3. Oh dear. I have 3614. 3614. I haven't placed my decimal yet. Let's use our logic and think about where the decimal goes. Well, 3, let's round 2.78 times 3. 3 times 13 is 39. So based on that, where should we put our decimal? Should we put it here? Heck no. Should we put it here, Evan? No way, Jose. I mean, no way, Evan. Should we put it here, Keishi? Yes. Keishi is nodding his head. Yes, that's the perfect place for a decimal. And now let's see if our answers match. So I have 36 and 1400ths versus 36 and 1400ths. Oh, happy day. You guys are brilliant. That was fun. Let's... Oh my gosh, you guys, look at this problem that I came across in our homework for lesson 26. It takes place in Chicago, so you know I had to do this one. So we have here number 5. The Aon Center in Chicago, Illinois is one of the world's tallest buildings. Built in 1973, it is 1,136 feet high and has 80 stories. If each story is of equal height, how tall is each story? Couple things. If you are ever in Chicago, do not call the Aon building the Aon Center. If you're in Chicago and you want to seem like you know what's going on, it's called the Aon building. No one from Chicago would ever call it the Aon Center. And
I go there all the time.
Yes, Mr. Calamaris is here live with me in the Calamaris living room. I imagine we both probably have friends that work in the Aon building, right? Here is a picture of the Aon building. It is this gorgeous tall building. This is Chicago in the summer. There's nothing better than this. This beautiful area right here is Millennium Park. There's a place for concerts right here. Mr. Calmaris and I have been to a lot of concerts. This shiny thing is called the Bean. It's this amazing sculpture. This street here is Michigan Avenue. This is the Art Institute in the lower right-hand corner. And then you can see Lake Michigan right through here. Oh, extreme close-up, thank you. And yeah, for those of you that have been to Chicago, you've probably seen the Aon building, not the Aon Center. It's gorgeous, and I'm thrilled that we have a word problem inspired around this magnificent Chicago structure. Okay, so let's get to the math part. We want to know, how tall is each story? You guys, in your infinite wisdom, know, well, and you can just see in this picture, each story, well, I guess this isn't really, well, you can't see the stories in the building, that's fine. We're talking about dividing each of these feet evenly into 80 groups. So I think you guys are already realizing, we're going to be dividing because that's basically all we've been doing lately. And you guys are basically experts at it by now, so let's just go for it. So we have 1,136 divided evenly into 80 groups. And let's see how tall each story is. So 80 goes into 1, no times. I'm not even going to insult your intelligence with putting a 0 there. 80 goes into 11, no times, okay. 80 goes into 113, 1 time. 1 times 80 is, oh, thank you. Georgie is saying 80. Good job, buddy. What a brilliant 6-month-old. 3 minus 0, Georgie? 3, thanks, bud. Also, Georgie wants you guys to know that he realizes that we can't take 8 from 1, so 1 is going to have to go next door and borrow. So we have 11 minus 8, which is 33. Okay, next we need to think about, Natalie, 33 less than 80. Natalie is shaking her head yes, so we can move on. Let's go ahead and move on and bring down our 6. Now we have to think about how many 80s can we fit into... How many 80s can we fit into 336? We can also think about how many 8s can we fit into 33. We can use our skip counting over here. So we have 8, 16, 24, or it's 80, 160, 240. I think we could probably fit one more. 8 into here. So let's try 4. I think 4 is going to be a really good next number for us. We are going to use our scratch paper on this side to see if we can fit 4 80s into 336. 0 times 4 is 0. 4 times 8 is 32. Okay, I think that's really good. So let's try our 4. Okay, so 4 times 80 is 320. We already did the work on the side. Thank you to Georgie. Now we need to figure out what is the difference between 336 and 320. Ava Lemon, 6 minus 0, thank you, 6. 3 minus 2, Ava E, 1. Beautiful. So now we have 80 and 16. Is 16 less than 80? Yes, we can move on. Oh, but we don't have any more numbers to bring down. We're not getting away with remainders anymore, you guys. So we're going to bring down 0/10ths. We worked on this in at the end of module 1. We're not getting away with remainders again, I'm going to say it. So we have to bring down our 0/10ths. So now we're looking at 160. How many 80s go into 160? I think it's probably obvious to Ethan. He's thinking, oh, there's 2 80s that fit into 160, Mrs. Calmaris. And yes, Ethan knows what he's talking about, but let's just prove that simple fact over here by doing 80 times 2 very quickly. 0 times 2 is 0. 2 times 8 is 16. Indeed, Ethan was correct. 80 times 2 is 160. Okay, so now we just need to do 2 times 80, 160. And then let's find our difference. Well, as Louis was already thinking, our difference is 0, which means that each story of the Aeon building is 14.2 feet tall. You guys are awesome. Have a great weekend, and I will see you Monday.
No.
Hey guys, Cal just woke up from his nap, and he was feeling a little jealous that Georgie got to be in the math video and he didn't. So can you say hi? Say hi. You stick out your tongue? Stick out your tongue. Say bye-bye.
Bye.